Good morning, student. In previous class, we study about electric field. Electric field, and also intensity of electric field. Electric field and intensity of electric field. What is electric field? Then the area in which if we take another charge, then it feel a electric force. Then the area is called electric field. And what is intensity of electric field? So it is represented by E. And the ratio of electric force F and test charge Q0 equal to intensity of electric field. Means the ratio of F and Q0 is called intensity of electric field. It is represented by E. Today our topic is electric field lines. Electric field lines. Electric field lines. We study about electric field, and the electric field is a area in which a test charge feel electric force. Is called electric field. Area in which a test charge feel electric force, then the area is electric field. And here electric field lines means if we take a test charge, we take a test charge in a electric field. हमने क्या किया है, टेस्ट चार्ज पुट कर दिया कहां पे, इलेक्ट्रिक फील्ड के अंदर में. मींस वी टेक ए टेस्ट चार्ज इन ए इलेक्ट्रिक फील्ड, देन द टेस्ट चार्ज feel electric force. Because in electric field every charge is feel electric force, which is made by a unit charge or point charge which is available in the electric field. Then we take a test charge in electric field, then the test charge feel electric force, and under the action of electric force, the test charge moves in a imaginary path. This imaginary path is called electric field lines. Means if we have a test charge, which is put in a electric field, then the electric field apply electric force on the test charge, and under the action of this electric force the test charge moves in a imaginary path, and the imaginary path is called electric field lines. Means the imaginary path in which the test charge in a electric field is moves is called electric field line. What is the definition of electric field lines? So the imaginary path in a electric field in which a test charge moves under electric force is called electric field lines. Properties of electric. Our next topic is properties of electric field lines. Properties of electric field line. There are many properties of electric field lines. First is, let us consider we have a surface. This is a surface. It is a surface. Surface is made by two axes. Here, if this is a electric field line and this is also electric field line, means if a electric field line is passes through, matlab enter in a surface and exit in a surface, from a surface, enter and this is exit. So this is enter in a surface and this is exit from the surface. Means the electric field lines exit and enter in a surface at 90 degree angle. At 90 degree angle. It is the first property of electric field lines. The electric field lines enters and exit at a surface at 90 degree angle. So this is the first, and which is enter and exit from a surface at 90 degree angle. This is the first property of electric field line. Then second, let us consider we have a positive charge and we have also a negative charge. Then the electric field lines passes through positive negative charge to negative charge. Positive charge to negative charge. Means electric field lines passes from positive charge to negative charge. Always the electric field lines passes through positive charge to negative charge. Means अगला क्या है, passes through positive charge to negative charge. This is the second property of electric field line. Next, the third property of electric field lines is, if we have only one charge, either positive or negative, only one positive charge, then here at first we consider a positive charge. Then according to electric field lines, they passes through positive charge to negative charge. Here we have only positive charge, then we assume the negative charge at infinity. We assume the negative charge at infinity means the electric field lines passes through positive charge and to infinity, because we assume the negative charge at infinity in the condition of one charge is available, and here positive charge is available, then the electric field lines passes through positive charge to infinity, and this is the third property of electric field lines. Passes through positive charge to infinity. This is the third property of electric field lines. Our fourth property is, here we have positive charge, then if we have only the negative charge, then we have only the negative charge. This is negative charge. The electric field lines enters at negative charge and exit at positive charge, means electric field lines flow between positive charge to negative charge. It starts from positive charge and ends at negative charge. Here we have available in negative charge, means the electric field lines enters at negative charge. Enters at negative charge, and in third property is the electric field lines exit from positive charge. Here enter at negative charge, then we assume that the positive charge is at infinity. Infinity. Positive charge is at infinity. Then we say that the electric field lines passes through infinity to negative charge. This is the fourth property. Passes through infinity to negative charge. This is the fourth property of electric field lines. Next, the fifth property is, if we draw a line at electric field lines. If we draw a line at electric field lines, then this is positive charge and this is negative charge. This is electric field lines. This is electric field lines which passes through positive charge to negative charge. Here, if we draw a line at electric field line, this is the line. स्पर्शरेखा, tangential line. This is the tangential line which draw at electric field line. Then this line represents direction of intensity of electric field. Number 3. If we draw a tangential line at the electric field line, then the tangential line represents the direction of intensity of electric field, and this is the fifth property of electric fields. The next property of electric field is, two electric field lines never cut each other. This is the sixth property of electric field. Two electric field lines never cut each other because this is positive charge and this is negative charge. The electric field lines passes through positive to negative charge. Okay. Here, if a line, electric field line cut other line, here, this is first electric field line and this is second electric field line. Both are cut at this point. If we draw tangential lines at the cutting point, then the more than one lines, this is first line and this is second line, more than one lines draw at the cutting points means this represent more than one direction of intensity of electric field at this condition, which is not possible. So two electric field lines never cut each other. Again, here this is positive charge and this is negative. Here this is the first electric field lines and this is the second electric field lines. This is first and this is second. At this point they cut each other. If we draw a tangential line at a electric field, it represents direction of intensity of electric field. Here at this cutting point we draw a tangential line. We draw another tangential line, means at the cutting point we have to draw more than one tangential line which represent more than one directions of intensity of electric field, and which is not possible. So two electric field lines never cut each other. This is the sixth property of electric field lines. The other property of electric field lines, the seventh property. The seventh property of electric field lines is, if at a point or at a area the electric field lines are more, then at this point the intensity of electric field is more. Means electric field lines is proportional to intensity of electric field. If electric field lines increases, then intensity of electric field is also increases, and if electric field lines decreases, then intensity of electric field is also decreases. So we can say that electric field lines is proportional to intensity of electric field. So if we have a area where intensity of electric field is very high, then the electric field lines is more available there. Or if we have an area where the electric field lines is very low, very short, then the intensity of electric field is very low at that area. Means electric field lines is proportional to intensity of electric field. And this is the seventh property of electric field lines. Today we study about electric field lines, which is, if we take a test charge in a electric field, then the electric field apply at electric force, and under the action of electric force the test charge moves at a imaginary path, and the imaginary path is called electric field lines. Means the imaginary path at which the test charge moves under electric force is called electric field lines. The property of electric field lines are seven, which are below. At the first property, electric field lines always enter or exit at a surface at 90-degree angle. Second, electric field lines always passes from positive charge to negative charge. If we have only one charge, then electric field lines passes from positive charge to infinity and from infinity to negative charge, which is this. Next, our fifth condition, if we draw a tangential line at electric field line, then it represents the direction of intensity of electric field. The other is, two electric field lines never cut each other, because if they cut each other, then at the cutting point we draw more than one tangential lines which represent more than one directions of intensity of electric field, which is not possible. And the seventh is, electric field lines are proportional to intensity of electric field. Means if a area have much electric field lines, then the intensity of electric field is very high, and lower then it is low. So it is proportional to each other. This is the properties of electric field lines. The other topic is, the next topic is electric flux. Electric flux. We study about electric flux in our next class. Thank you.